Starting section 4-6 today, so there is more graphing here, believe it or not. We've already done sine and cosine. That was pretty much all section 4-5 stuff. So here in section 4-6, we're going to learn how to graph all the other trig functions. There's 4 more. So today, actually, we're only going to focus on tangent and cotangent. Tomorrow, we'll do secant and cosecant. And then Monday, we'll just kind of put all 4 of them together and do some other things. So 3 parts to this section. I think we had a little bit more in 4-5. So the way I'm going to start this out is I'm going to put up here what the parent functions look like for tangent and cotangent. You will want to have this stuff down because once we start our examples, you have to know how the parent functions started out. So we're going to go with y equals tangent of x first. Now, for your coordinate plane here, it can really be centered around the origin. It's not really shifted over, kind of like the sine and cosine looked like they were more on the right. This one, for the most part, is smack dab in the middle. And then let me start to label this with you. You just do whatever I do up here. The first important x value that you're going to want to have is negative pi over 2. I'll show you what's there here in a minute. And then you really don't have to label 0, but we're going to have to put something there as well. And then on the other side, I'm going to have positive pi over 2. Those are the important values that you need along the x-axis. Now, it turns out with tangent and with cotangent, there are vertical asymptotes involved. We didn't have that with sine and cosine. Sine and cosine were continuous curves, but tangent and cotangent are a little bit different. So you don't have to have a different color necessarily, but go ahead and draw a dotted line straight through the negative pi over 2 and another one going through positive pi over 2. Those are actually vertical asymptotes. So remember, you can get really close to them, but you can't touch them. It's kind of like a boundary. Now, the next thing that I'm going to put up here is the first point that you're going to graph. There is what I'm going to call here in a second, there is a center point for tangent right there at the origin. And then to fill in a couple more points on this graph, I'm going to use the amplitude to help me a little bit. Now, even though this is a different trig function, a is still the number out front, so that would be 1. Absolute value of 1 is 1. So you don't really have to label that since you've got lines on your paper. But let me describe to you how to get a couple more points up here. The first thing I want to tell you is the shape of a tangent graph is similar to the shape of a cubic function. We haven't done those since pre-calc, but a cubic function starts down here to the left and goes up to the right. It didn't have asymptotes, but it's the same kind of shape, down to the left, up to the right. So watch carefully how I can estimate a couple more points on my graph. If you take your pencil and go about halfway between the center point and the left asymptote, I'm not asking you to label that, I'm just asking you to go there. And then since it goes down to the left, I'm going to bring my pencil down to wherever my amplitude tells me. In this case, it's down to -1, and there would be another point on your graph. On the other side, since it goes down to the left and up to the right, I'm going to go about halfway between these and go up to wherever my amplitude tells me, and that would be up to +1. Again, I'm not asking you to label those X's. You just go about halfway between, and then that side should be down, that side should be up. So here it comes. It is, again, very similar to the shape of a cubic function, except this has asymptotes. So it's never going to cross these. It's going to just keep getting closer and closer. Now, this is what we use for our parent function, but I do want to point out that even though there are asymptotes, the graph for a tangent function actually does continue to go all the way out to the right and all the way out to the left. I'm going to show you that real quick on my graphing calculator. You can just look up here for this part, but I've got tangent of X in there. And you can see from this graph, it's not just that chunk. It technically repeats over and over to the right, over and over to the left. But the only chunk that we use for our parent function is this one right here, centered right at the origin. Now, once we have our graph done, I'm going to kind of summarize what we just found on this graph, and I'm using really technical terms here. I'm going to label this important stuff. You're going to see, once we start our examples today, why this stuff is important. All right, so I'm listing out what we found on this side. We found that tangent has a left asymptote at negative pi over 2. I'm pretty well just kind of pointing out the important X values on this graph. There was a left asymptote at negative pi over 2. There was a center point where X is 0. So again, I'm just kind of talking X values. I didn't write that as an actual ordered pair. I'm just telling you, and you're going to use this later, center point was at 0. And then you can see from the graph, the right asymptote is at pi over 2. Question?
Will we have to do the dotted lines? Or?
Yes. Yes, please draw them. That way I know exactly where the boundary is so you know where you can't cross. Okie doke. I'll come back to this stuff here in a second. Like I said, that listed out in that way is going to help us later on when we start to do some of our examples. Now let's do the same thing for cotangent. So y equals cotangent of x. This graph is not going to be centered at the origin. It's going to be shifted over kind of to the right a little bit. So notice on my coordinate plane that I left more room on that right-hand side. Okie doke, and I'm just going to go through all of the important stuff on a cotangent graph. All right, the first x value I'm going to label as 1. You don't necessarily have to label, but 0 is going to be important to us. All the way at the end here, I'm going to put pi. And then halfway between, I'm going to label that a pi over 2. So here's what happens on a cotangent graph. Instead of having asymptotes at negative pi over 2 and positive pi over 2, the asymptotes are actually at 0 and pi. So again, draw some dotted lines there to show that that's not really something on your graph necessarily. That's something you can't cross. And the pi over 2, that's going to end up being our center point. All right, and just like last time, I'll use my amplitude to help me find a couple more points on this graph. Amplitude is 1 again, so you don't necessarily have to label that. But here's the big difference between tangent and cotangent instead of going down to the left and up to the right, cotangent is actually up to the left, down to the right. So when I come halfway between my center point and my left asymptote, you don't have to label what that is. But whatever it is, I know I need to go up to wherever my amplitude tells me. So that would be up to 1. On this side, halfway between the center point and the right asymptote, I need to go down to wherever my amplitude tells me, and that would be -1. So pretty much the tangent and cotangent graphs are flipped around from each other, but also the asymptotes and the center points are in different places. Okie doke. Now, summarizing the important stuff for cotangent, I'm going to refer back to this important stuff here in a minute. The left asymptote is where x is 0. The center point is at pi over 2. And then the right asymptote this time is at pi. The reason I'm pointing that out is because those values are going to change on some of our problems. If the period changes, then some of those might change. Now, that was kind of a good segue. Speaking of period for just a second, does anybody remember with the parent graphs for sine and cosine, how long did those go until they started to repeat? 2 pi. Well, take a look at tangent and cotangent. These graphs, and it's a little bit easier to see it on the cotangent graph, these graphs only go a length of pi before they start to repeat. So I'm going to put that down here as well because that is very important to notice. The period for y equals tangent of x and y equals cotangent of x is pi. That's a big difference, and I'll tell you a little bit more about that when we start to do the periods later on with the examples. But the period for tangent and cotangent is actually pi instead of the 2 pi that we had with sine and cosine. Okie doke. Now, after that, once you get that part down, I'm going to put the directions back up here. They're really the same directions that we've had the past few days. So if you want to put, like I mentioned the other day, if you want to just put same as earlier or something like that, that would be fine. It's the very same thing. Clearly state the amplitude and period. Period is going to be different today though. We'll talk about that. Then sketch a graph. Include one full period. Label all of the important spots on both axes. Okie doke. Tangent and cotangent. They all have 2 asymptotes, a center point, and then you use your amplitude to kind of fill in the rest. Okie doke. I may not leave that up there too long because again, it's the same directions that we've had for the past few days. So let me start with this one. Example 1 says y equals tangent of 2x. Not tangent of x, tangent of 2x. Okay, the directions said to state the amplitude and the period first. So going back to amplitude, it's the very same formula. Absolute value of A. A is still the number in front of the function, so absolute value of 1 is just 1. Now here comes a big difference today, so pay close attention. With sine and cosine, to find the period, we took 2 pi divided by b because the period of the parent graphs was 2 pi. Well, period of these parent graphs is just pi. So I'm putting that together kind of as a rule over on the side to find the period for tangent and cotangent. You don't take 2 pi divided by b. All you do is take pi divided by b. And again, the difference there is just the period of the parent graphs. Used to be 2 pi, now it's just pi. So the b part hasn't changed. B is still the number in front of x. So for this problem, b is 2. And so I just need to take pi divided by 2, and I can't really simplify that. So I'll just leave it as pi over 2. Okie doke. We are not just going to put pi over 2 at the end of our x-axis and find all the halfway points. We have to do it differently with tangent and cotangent. So I'm going to put kind of another rule up here for what to do next. Anytime your period changes, and what I mean by that is the period used to be pi. So anytime it's something other than pi, like pi over 2, this is what you have to do to find what I call the new important stuff. Very technical today. To find new important stuff, the stuff is like your x values, so maybe in more detail here, to find new x values, you want to divide the old x values, or the old important stuff, by b. That's very important. Divide the old important stuff by b. You do that anytime the period has changed from pi to something other than pi. Okie doke. So I'm going to show my work for this right underneath of here. My function is tangent. So go back to the list that we made for the important stuff with tangent. Okay, and I'm going to try and keep things short and sweet here. So instead of actually writing out left asymptote, I'm just labeling that LA, left asymptote. Where was the left asymptote for our tangent graph? Negative pi over 2. Take the old important stuff, which right here is the negative pi over 2, divide that by b. Now what was b in this problem? 2. A common mistake that I see here is that people will take the old important stuff and divide it by the period. You don't use the period here. You divide it by b, which was the number in front of x. Now this is going to require a good old keep change flip to figure out what that actually is. So it's like taking negative pi over 2 times 1 over 2, and that would simplify to negative pi over 4. That's where your new left asymptote will be, negative pi over 4. Okay, the next thing on our list was the center point. I'm getting lazy again. Instead of writing out center point, I put CP, center point. All right, the old center point for tangent was at 0. So I take the old stuff and I divide it by b, and actually it stays the same here. 0 divided by anything is just 0. So I still have a center point at 0. And then the right asymptote, RA, as I like to call it, it was at pi over 2. So take that, divide it by 2. It's going to be the same thing that you had up here, but it'll be positive pi over 4. These are the x values that you need to label on your x-axis. Again, you don't necessarily have to label the 0 because it's just 0, but everything else needs to be up there. All right, I'll come over here a little bit. Say that is negative pi over 4. Try and keep things equal here. So that would be positive pi over 4. Now, the amplitude is just 1. I'm going to go ahead and label that up here real quick. So, the points on the end are not points at all. They are asymptotes. So, we'll draw some dotted lines for that. Now, the 0 is the center point. So, it's exactly what that said, center point. And now, to fill in the rest, I need to go back and remember what function I'm using. I'm using tangent here. And if you go back to the parent graph for tangent, it starts down to the left and goes up to the right. So I'm going to go about halfway between the center point and the left asymptote. You don't have to label that, but just bring that down to wherever your amplitude tells you. And then about halfway between right there, I'm going to move that up. And then I just need to connect them. So again, do draw the dotted lines. That way you know what you have to stay between. But that would be it for number 1. Pretty much the only thing that was different was where those asymptotes were. Okie doke. Questions about that? To summarize, you always take the old stuff divided by b if your period changes. It used to be pi, so if it's something other than pi, then you have to go through those steps. All right, example 2, y equals cotangent of x divided by 3. Cotangent, so the shape is going to be different this time. But first of all, what is the amplitude? 1. That's kind of nice again. And for the period, I have to take 1 pi divided by b. Now, what is b here? 1/3. We had that happen a while ago. X over 3 is the same as 1/3 x. So this looks kind of weird, but I'm taking pi divided by 1/3. Now this also requires a good old keep, change, flip. If you flip over a 1/3, you get a 3. So pi times 3, that's just 3 pi. The period here is 3 pi. And I notice it's different than pi. So now I have to go through my old important stuff for cotangent, and I have to divide all of that by b. So looking back at your parent graph for cotangent, where was the left asymptote? 0. Take that 0 divided by b. Well, 0 divided by anything is still just 0. So let me move on. The center point for cotangent used to be at pi over 2. So take that divided by b. Again, you don't divide by the period. You divide by just b. And I'll have to keep, change, flip right there. That works out to be, I guess I'll leave it as 3 pi over 2. That's something you'll have to label on your x-axis. And then the right asymptote used to be at pi. So take pi divided by 1/3, and actually that's kind of what you did up here. Pi divided by 1/3, that's going to end up being 3 pi. So that gives me everything I need to label my x-axis. Y-axis is still pretty standard here since the amplitude is still just 1. All right, let me catch up here to the PowerPoint. Now I'm going to say, well, here's 0. So then that can be the 3 pi, that can be the 3 pi over 2. So an amplitude of 1, there's that. But remember, this is cotangent. I better put my asymptotes there before I forget. There we go. Now, cotangent starts up and then goes down. So about halfway between right here, I'm going to go up to positive 1. Go ahead.
So with the periods, if it wasn't pi, then you divide by whatever you got?
If it's not pi, if the period is not pi, you always divide by b. That's just kind of what you do. Always divide by b. That just puts your new stuff in the right places, basically. Now, I'm doing cotangent again. So up to the left, down to the right. I'm going to go halfway between over there, down to my amplitude of -1, and there it is. We will see an example here in a little bit where it flips. You'll see a negative out front, but just to kind of give you a heads up on that, if you flip a cotangent graph, it'll look like a tangent graph. So like if that actually had negative cotangent of x over 3, I would have done it like a tangent graph, down to the left, up to the right. If there's a negative in front of a tangent, then it basically just looks like a cotangent. All right, I've got 2 more examples here, so stop me if you have any questions. Number 3, y equals 1/2 cotangent of 2x. 1/2 cotangent of 2x. What would our amplitude be? 1/2. Now, the period is going to be different because it's not just cotangent of x, it's cotangent of 2x. So I have to take that pi and divide it by 2, and I'm just going to leave that the way it is. Period is pi over 2. That is different than the parent function. So I need to go through these steps another time to figure out where my new values will be. Now we just did cotangent. So the left asymptote was at 0. Divide that by b. Well, 0 divided by anything is still just 0, so that didn't really change. The center point used to be at pi over 2. Remember, divide that by b, not the period. Divide it by b, and if you keep change flipped, you'll end up multiplying by 1/2 right there. So that'll be like a pi over 4. And then right asymptote was at pi. So take pi divided by 2, and you can just leave it like that. Pi over 2. Okie doke. So you'll start to find that cotangent, you need like the right half of the graph. Tangent, most of the time, unless it's shifted, it's more centered around the origin. Okay, but amplitude is different here. So I'll try to kind of explain a couple ways that you could do that. That's pi over 2. I'll call that pi over 4. So this is a vertical asymptote. That is a vertical asymptote. And here's the center point. Now, because the amplitude is not 1, you can try to go about halfway up from your line and call that 1/2. Halfway down, call that -1/2. Or even if you go a full line up to label, that's okay too. But make sure and actually put 1/2 and -1/2. Anytime you count by something other than 1, you should really label what that number is. Okie doke. This is cotangent. So starts up and goes down. Now the 1/2 is going to make kind of a vertical compression on this graph. When I go halfway between right there, I only go up to 1/2, and then halfway between right there, I only go down to -1/2. You might not be able to see the compression very well if you went up a full line, and that's okay again, just as long as you label, but it should be a little bit flatter than usual. Okie doke. Questions on that one? I'm going to try just one more with you. Number 4, y equals -2 tangent of pi over 2x. -2 tangent of pi over 2x. What is the amplitude? 2. And the period, this is kind of weird, but I have to take pi divided by pi over 2. Period. Pi divided by pi over 2. Now, I'll keep, change, and flip right there. So the pi's actually, if you kind of put that one over 1, the pi's will cross out, and you just get a little old 2. There's not even a pi with it. The period is just 2. That is different than the parent function. So here we go one more time together. I need to find where my new important stuff is. Where was the left asymptote for the parent graph of tangent? -pi over 2. Take that divided by b. Now here's a quick way to divide right there. Forget the negative for a second, but what do you always get if you take a number divided by itself? 1. But a negative divided by a positive is a negative. So that would just be -1. The center point is still going to be at 0. And the right asymptote, I need to take pi over 2 divided by pi over 2. So anything divided by itself there would just be 1. Very good. Now I just need to get these on my x-axis. I'll call that -1 and that +1. So can't cross right here, can't cross right there. It is a tangent graph, but it's been flipped. Now I should probably put my amplitude up here. You can just use the lines on your paper to do that part, but it does need to go with a 2 and a -2. So instead of down to the left, up to the right, it is flipped, so it actually resembles more of a cotangent graph. Halfway between right there will be going down. It is kind of a vertical stretch here, so it should look a little bit taller. Alrighty, questions about any of that? Pretty good stuff there. You still have almost 15 minutes left. So this is T22 from page 311. We're actually in the textbook, not a worksheet today. We'll do 9 to 14, and I don't really know what the book uses for their directions, but I think they're different than ours. So just an FYI here, use our directions, find the amplitude, find the period, and then do it exactly like we did in the notes.